In this video, we're going to learn about using molar mass as a conversion factor. So here's a problem. A sample of sodium fluoride has a mass of 31.5 grams. How many moles of sodium fluoride does it contain? The first thing that we need is the molar mass of sodium fluoride, and if I look up sodium on the periodic table, I find that it has 22.99 grams per mole, and fluorine has a molar mass of 19.00 grams per mole, and together their sum is going to be what, 41.99 grams per mole. And that will be my conversion factor because I always want to start with a measurement that I'm given with dimensional analysis. I always start with whatever measurement I'm given, 31.5 grams of NaF. And I'm going to multiply this by a conversion factor that will get me to, it's asking for moles. So I start with a 31.5 grams. How many moles? So moles of NaF. So what I do here is I put moles on the top of NaF, and on the bottom, I'm going to put grams of NaF. I know that 1 mole of sodium fluoride has a mass of 41.99 grams because I did it over here. And so if I do the arithmetic out, I find that the sample contains 0.750 moles of sodium fluoride with the correct number of sig figs. I'll note that, as promised, the limiting factor here on sig figs is not the molar mass, because it never will be. It is the measurement given. You could also do this type of calculation in reverse. If we need 0.25 moles of sodium fluoride, that's our measurement to start with. So I'm going to say 0.25 moles, moles of NaF. And I'm going to multiply this by, this time I'm going to have 41.99 grams over 1 mole. The moles cancel out, and I end up with, 10 actually, 10 grams of NaF. This is only to 2 sig figs because apparently I was only asking for 2 sig figs. This is 0.25 moles. So if we move on, here's a challenge problem, just to expand our thinking on the dimensional analysis here. How many hydrogen atoms are there in 27.0 grams of water? I'd first need to figure out the molar mass of water. For oxygen, 16.00 grams per mole. For hydrogen, we have 2 times 1.01 grams per mole. And together that gives us 18.02 grams per mole. What else could be a useful conversion factor here? Well, I'm looking for hydrogen atoms. I know that there are 6.02 times 10 to the 23rd atoms per mole, but I'm looking for hydrogen, not just atoms in general in the molecule. So I need to figure out how many moles of hydrogen there are in a mole of water, and I know that there are 2 moles of hydrogen atoms for every 1 mole of H2O. That's what that 2 is for. That 2 subscript represents the 2 moles of hydrogen per mole of water. So with all this in mind, with all these conversion factors figured out, I start with my initial measurement, my 27.0 grams of H2O, and I know that I'm going to need 3 conversion factors. And these 3 conversion factors will lead me to my final answer of H atoms. First thing I'm going to do is I'm going to get rid of grams. and grams of water. And of all the conversion factors here, the only one that has grams of water is the molar mass. So I'm going to say 1 mole H2O for every 18.02 grams of H2O. I'm being very, very deliberate with my units, like even labeling H2O. In many cases, it might not seem to matter, but I think in cases like this, where it gets a little bit more complicated, this can actually help you out. For example, I'm going to now use this next conversion factor, 2 moles of H for every 1 mole of H2O. If I don't write out hydrogen and water, I don't necessarily see this canceling out. I'd have moles here, and then I'd have moles over moles. And would I be putting the 2 in the correct place? I think labeling out moles of hydrogen and moles of water is an important thing here, because you'll see your mistakes if you're making them. And if you're not really paying careful attention and you don't put in the units exactly as they should be, you might make a mistake. My last thing here is I need 6.02 times 10 to the 23rd H atoms per 1 mole of H. And so my moles of H cancel, and I'm left with my last unit standing. My unit on the left is H atoms, my unit on the right is H atoms, so I've set this up correctly. From here, it's just a matter of the arithmetic. If you're using a calculator, which I would, 27.0 times 1 divided by 18.02 times 2 divided by 1 times 6.02 times 10 to the 23rd divided by 1, that equals 1.80 times 10 to the 24th H atoms. 3 sig figs, 3 sig figs. In fact, I'll point out that a nice little strategy might have been seeing this at the very beginning and kind of going towards the end of your problem and just writing 3 SF or 3 sig figs, so that you're kind of reminding yourself when you get over here, it's been a while since we started the problem. Oh yeah, I should make sure that my answer has 3 sig figs. Just something to keep in mind that could help you. But our answer, of course, is this. And I hope this video has been helpful. Let me know if you have any questions or feedback in the comment section below. Thank you.